Hi guys, welcome back to the workshop. Today what we're looking at is taps and tapping. In the last video we used taps to create a threaded hole for a camera stand that I made, and I wanted to go into it in a little bit more detail. Now what taps are is a tool for cutting a thread on the inside of a hole in whatever material. That could be plastic, aluminium, steel, whatever. The purpose of the threaded hole is that you can use a fastener such as a bolt to attach something to that material, and it can also be used for cleaning out existing holes as well where there might be rust or dirt or whatever. And do bear in mind though that if you have to use a tap to cut rust out of a threaded hole, you're not dealing with pristine material, and you will be looking at a degradation in strength or gripping capability of that fastening. Now, tapped holes come in two varieties. Number one is a through hole, whereby we go straight through the material and we have access to the rear of the hole. And the second type then is a blind hole. The blind hole just needs a few more steps or a little bit more calculation, as when you're cutting threads, you won't be able to cut threads down to the very bottom of the hole. So you'll have to drill the hole slightly longer to allow a full thread form or space for a full thread form to match the length of your fastener, and then a little bit extra whereby the tap itself mightn't cut a thread all the way to the bottom of the hole. So the order of operations when we're making a threaded hole is: number one, we drill a hole of the correct size and we'll call that a pilot hole. Number two is we'll countersink the opening to the hole, which is basically just sort of a widening and at an angle to the mouth of the hole. This helps guide the tap and any fastener that we have to use then afterwards. And the third step is we use the correct size tap to cut a thread. Now on the bench here I've three sets of taps, and in the last video we used these 1/4-20, which are a 1/4 inch in diameter and then 20 threads per inch as regards the number of threads that we cut. The other two sets then are metric. This here is sort of an all-in-one set for cutting M8, M10 and M12 threads. It comes with two different types of taps and the drill bits which are suitable for drilling that pilot hole. It also comes with a countersink bit there, and I'll see, yeah, we can see that there. So sort of it's an all-in-one set, so to speak. And as we can see there on the label, the drill bits are 6.8, 8.5 and 10.2 millimeters, and they match up then with the required pilot holes for an M8, M10 and M12, which are 8 millimeter, 10 millimeter and 12 millimeter nominal fasteners. Now, just in that particular set, there's two taps per set plus the drill bit. And generally speaking, a full set of taps comprises of three different taps. The first one, and we'll try and get it into focus there now, is you'll notice there that the thread form doesn't become fully formed until 7 to 10 threads up the shank of the taper. So that's what we start the hole with. The next one then is called a plug tap. And what we have there now is there'll be sort of a fully formed thread, about 3 to 5 thread forms up the shank of the tap bit. And then the last one, which we finish with, is called a finishing tap or a bottoming tap. And what we'll have there is sort of fully formed thread cutting capability as far down as possible effectively. Now, one thing to note is that when we are using our taps, that the taper tap or the starting tap will not have the full width of the tap in a lot of cases. So we'll measure that there, and we're looking at 10.75 millimeters, which is a good bit away from a 12 millimeter nominal size. The plug tap, which is the middle one, we'll measure that on the very outsides, and we're coming in at 11.52. So as you can see, there's a progression of width cutting there. And then if we measure the last one then, which is our bottoming tap, we come in at 11.91, which is very close to our 12 millimeter nominal value. So just be aware that if you do get a set with two, the taper tap will be the one for starting, quasi cutting the threads, and then it's very important to finish out with the bottoming or the finishing tap at the end. Now, As regards selecting the size of drill bit to use for our pilot hole, what we're trying to achieve here is that we want the sort of the pilot hole to be the width of the central shank of the fastener that we intend to use in it. So if we measure this bolt, which is an M12 or 12 millimeter bolt, and we get the teeth of the caliper in there, right? We're looking there at 10.18 millimeters, and that'll match up then, or you'll see how it matches up with the 10.2 millimeter drill bit in the set. The same would apply to quarter 20 or imperial sized, and I know that for the quarter 20 we need a 7/32 drill bit. That'll be the correct one to use there. Now, when we start cutting the threads, we'll start off with the taper one, and the taper tap is designed to effectively fit into the pilot hole so that you stand a chance of getting a straight cut thread. The way we clamp onto that is with this fella here. This is a tap wrench, and it says here 5 to 20 or 7/32 to 3/4. And you'll see there that there's sort of a square mounting mechanism there, which is sort of like a little vise or whatever. And the bases of the taps themselves are square, and one of those slots in there into that square hole, tightens it up, and that's how you use those. Now, if you have access to a bench drill or a mill or something like that, there is another little tool as well, and this fella here is called a tap follower. And on a bench drill, what we do is we'd use the bench drill to drill the pilot hole, without moving anything really except the quill up and down. We'd mount this in the chuck, and then the bottom of this is spring loaded. And if we look at our taps as well, and any of the bigger taps will probably have a little receiving point there that you can actually put a tap follower into it. You'll pull down the quill, and that'll put sort of a preload on that spring. And then as you turn this, the pilot hole will take one end of the tap, and then the tap follower then will hold the other end of the tap and sort of give you a better chance at making a sort of a properly square threaded hole. So we'll move on to a practical example now of cutting a thread. We'll do that. I have a job to do on the bench. Before we move on there though, I would say that a good recommendation is the drill bits for matching up with taps. They're not as commonly available as the normal drill bits. So let's say if you go into a shop, you can very easily pick up an M6, M8, M10, M12 drill bit. A 10.21 or an 8.51 or a 6.81 are much more difficult to get. So I'd strongly recommend using normal drill bits to start the hole. And in this particular example now, where we'll be cutting an M12 thread and using a 10.2 mil drill bit, I'll start out with a 6 mil drill bit, drill a pilot hole, I'll up that to 8, and then we'll move on to the specialist drill bit then to try and save that rather than stand a chance of breaking it. Now what we have here, and it's a sort of an example or sort of a practical demonstration with a sort of a useful outcome to it. What we have here is the rack that I made up for holding hammers just on the edge of the bench. But what I found was that the handles of the hammers as they sat in here, and I'll stick up a picture, were interfering with a rack that I had for the grinders. So effectively what I did was cut this off, and what we're going to do is just invert it. We'll drill a hole and thread a hole into the bench to accept a little plate like that, and then mount the hammer rack on top of the plate in such a way that it can swing in and out and come out of the way. Now we've drilled our pilot hole, so we started off with a 6mm bit, went to an 8mm bit, and then finished out then with the 10.2mm bit, which is the one we want for our M12 threaded hole. We've also used the countersink, and it tidied up the top of the hole, and it'll also provide a guide for the tap to go in straight. Now when we are tapping, very important to use lubrication. This stuff here, I just flashed it up there earlier. This is cutting and drilling paste, perfect, made by Worth. And effectively what it does is just stops the teeth binding into the material, and it'll give you a longer life on your taps and drill bits as well. And don't be shy with it. Right. Now we're starting off with the taper tap, which is the one which has the threads only forming after 7 threads or thereabouts. Okay, so we tightened into the tap wrench, and what we'll do now is we'll start it off, and the countersink on the hole will help us in guide us in as well, and that provides a good advantage. And when we're starting off the thread, very important to keep it as straight as you can. If you feel it getting wobbly, just turn it gently, steady it up with your hand, and as you progress then you'll feel the thread starting to cut. It'll be gentle at first, and then as the tap progresses through the hole, there'll be more and more resistance, and when you come to the point where there's a lot of resistance, that's when you back off and you break the chip. So we've done a full turn there, and we'll just back off, and you'll feel the chip break, and there'll be a slight bit of resistance going in reverse, and then when the chip breaks, it'll run free. So we just keep progressing gently like that all the way through, gently but firmly, would be the best way of approaching it. So keep turning, and we'll feel it starting to bind at some point, and then we reverse again, break the chip, keep going. So we're progressing nicely now, and I can feel that the threads are cutting strongly, and they're breaking off nicely, and we're making progress through the way. So you keep doing that away. Again, sort of gently but firmly. And I think we're through now because the tap itself is running free in the hole. So we'll back that off, and we'll change to the finishing tap just to make sure that we have every thread covered. Now, don't drop your taps either, because again, they're sort of quite brittle because they're hardened. And now, the moment of truth. Let's stick our M12 bolt in. So, job done with our M12 thread cutting.